Number 7, redox reactions and electrolysis. So, the redox reactions are pretty simple. We just have to figure out their charges and oxidation numbers and do a little math, but just counting and stuff like that. And electrolysis is pretty simple as well, but more reading and comprehension than mathematics. So 7.1 just goes into what is a redox reaction, just a basic definition. Oxidation, you gain of oxygen. So for example, magnesium reacts with oxygen, you make MgO. That is an oxidation reaction. Magnesium is being oxidized. Okay, loss of oxygen is reduction, which is the opposite, which makes sense. So copper oxide plus hydrogen yields copper plus water. So copper oxide is the one being reduced because it loses oxygen. Alright, so redox reactions always take place, oxidation reduction always takes place together, which makes sense. You can't have a reoxidation or a doxox reaction, it's a redox reaction, which represents reduction and oxidation. You can have different reactants to be reduced and oxidized at the same time. So you can see here CO2 when it reacts with water. C parts of the oxygen go to the sugar and water, and some of the oxygen from water goes to oxygen, and the hydrogen goes to both the carbohydrate and water. Other definitions you can see: oxidation loses an electron, so glucose is being oxidized, and the coenzyme is being reduced. Just other places you can see redox reactions occur. The one that's being oxidized is the reducing agent, as you can see here below the A. And it loses electrons, so it has 0 electrons here, and the coenzyme is the oxidizing agent, which is being reduced, which gains an electron. So, also another way to describe oxidation is the removal of hydrogen from an organic compound. So that means reduction is the gaining of hydrogen of an organic compound. Alright, quick homework question first. You want to determine if the reactant, or which reactant is being oxidized, and then in B, which reactant is being reduced. So remember, oxidize is the gaining of oxygen, and reduction is the losing of oxygen, or gaining of hydrogen. Alright, 7.2. Now how you can determine oxidation reduction by numbers is simple. You can find the oxidation number for each element, and then that will tell you if it's been reduced or oxidized. So for example, we have CO2 plus H2 yields CO and water. Oxygen is simple. It's 99% of the time is -2 charge. We know that from the periodic table. So all these oxygens don't change. They stay at -2. Here, since oxygen is -2, that means carbon has to be a +4, because there's 2 oxygens. 2 times -2 is, or 2 times -2 is -4, so a carbon has to be +4. An element is always 0. To balance out the -2 of oxygen, carbon has to be +2. And to balance out the -2 from oxygen, hydrogen has to be +1 because there's 2 hydrogens. +1 + 1, and a -2 gives you 0. So reduce means the number gets reduced. It goes from 4 to 2. So carbon is being reduced. In oxidation, the number is increasing. So it goes from 0 to 1 for hydrogen, so it's being oxidized. So, what's that determined in oxidation? Oil. Oil means oxidation is losing of electrons, and reduction is gain, oil rig. You also may have heard Leo goes Gur, it means the same thing. So for Rig, its reduction is gaining, oxidation is losing electrons. So we can see how these are losing or gaining electrons by half reactions. Half reaction is obviously half the full reaction. So sodium plus chlorine yields sodium chloride, pretty simple reaction. You can break that part into sodium making sodium ion, which then loses an electron. Okay, loses that electron equals oxidation. And chlorine gains 2 electrons and it is being reduced. Okay, so Leo goes Gur, or oil rig, is the way to remember which one loses and which one gains. Now to balance it out, you have to multiply the sodium equation by 2 because there's 2 electrons in chlorine that need to be canceled out. Electrons always have to cancel out. And that gives you the overall reaction of 2 sodiums plus chlorine gas yields 2 sodium chlorides. Okay, here's another full reaction that you can split apart into half reactions. Iron gets oxidized because it's losing 2 electrons. Copper is gaining 2 electrons, so it's being reduced. The electrons cancel out, and you get the overall reaction of iron plus copper. Aqueous copper yields aqueous iron plus copper solid. Notice the charges are balanced on both sides, +2 on the reactant, +2 on the product. Here's another way to show the canceling of electrons. Notice silver had to be multiplied by 2 to get the 2 electrons to cancel out from copper, and you're just left with a simple single replacement reaction. Alright, rules to redox reactions. You must balance the charges with your electrons, so electrons have to cancel. If you're in an acidic solution, you always add H+. If H+ is added, you must add water to the other side. And you must make sure the electrons are the same value, coefficient, so they balance out and they cancel. Alright, construct the balanced ionic equation for the reaction of iodine ions with manganate 4 ions in the presence of hydrogen ions, so we know it's acidic. So the first half reaction, iodine gets produced to make iodine diatomic. We got to add electrons, so electrons are going to be added on the product side, 2 of them to balance out the 2 negative on iodine. Here is our manganate ions, MnO4. Hydrogen gets added. That means water gets added on the product side. And you're left with Mn2+ on the product side as well. This has to be balanced a little more difficultly. So we have 4 waters to balance out the oxygen, 8 H+ to balance out the H, and to make sure our electrons cancel, or to balance out, we need, let's see, +8 minus 1 is +7. So we need 5 electrons to give you a +2 charge. So everything's balanced in the half reaction. Now we gotta combine the 2 half to get a whole, and this is where you have to balance out the electrons on both. So we have 2 electrons in the iodine, 5 in the manganate. So the most common multiple is 10. So you gotta multiply the top by 5 and the bottom by 2. So we get 10 yields 5I2 plus 10 electrons, and then you get 2 and 16 hydrogens plus 10 electrons, and 2 manganates plus 8 waters. The electrons cancel out, and you get the overall reaction combining the 2 together to get your balanced ionic equation. Alright. You want to write 2 half reactions for the following reactions and state whether it's being oxidized or reduced. And then on the second question, zinc reacts with iodate ions in an acidic solution. You want to construct a balanced ionic equation for this reaction using the two half reactions below. So you gotta make sure you balance it out so the electrons cancel. Alright, 7.3, oxidation numbers. So the oxidation number is something you know. It gives each atom or ion in the compound, which shows us its degree of oxidation, which basically represents the charge of an atom. If electrons transfer completely to the atom, and you have a greater attraction for them in a given situation. So you're either going to have plus, minus, or neutral. The more positive means more oxidized. That means they lost more electrons. And the higher the negative, that means more reduced, so they gained more electrons. Here are the rules. A oxidation of like uncombined elements, so basically an element is always 0. Here's your fixed oxidation numbers, which you always know. +1 is your alkali metals, +2 is your alkali earth. Fluorine is -1. Hydrogen's +1 except when you have metal hydrides, it's -1. Oxygen is -2 except peroxides when it's -1. And in FTO where it is +2. So basically 99% of the time it's -2. It's got to worry about the peroxides and FTO. The oxidation number of an element in a monatomic ion is always the same as the charge. So for example, chlorine is -1 means it's -1. Al3+ means it's +3. The sum of a compound is always 0, or it is the sum of the ion charge. In either a compound or an ion, the more electronegative element is always given the more negative number, which makes sense because they want more electrons. Alright, so here's some examples. Non-metal, non-metal, pretty easy. Determine the oxidation region compound, so SO2. Oxygen is always -2, therefore the total charge is -4 because there's 2 oxygens. 2 times -2 is -4. Thus, sulfur has to be +4 to make it neutral. N2H4. Hydrogen is always +1, or is +1 in this case because it's less electronegative than nitrogen. Therefore, there's 4 hydrogens. Thus, you have a total charge of +4. That means the charge for each nitrogen has to be -2. Because there's 2 nitrogens, so you break down -4 to divide by 2, you get -2. Compounds and ions. So, nitrate ion, you have a total charge of -1, so that's your goal. Oxygen is -2, therefore a total charge of -6 because there's 3 of them. So that means nitrogen has to be +5 to give a -1 total charge. Perchlorate, ClO4 -1. Oxygen -2, therefore total charge is -8. So that means chlorine has to be a +7 to give you a -1 total charge. Alright, here's a few questions. You want to do the ones that are bold, which for A is phosphorus, B is sulfur, C is sulfur, D is aluminum, E is nitrogen, F is chlorine, and G is carbon. You want to give the oxidation for each of the bold atoms. Alright, we are going to go over more reduction oxidation in class. These are the slides that you can view. Obviously, with oxidation, you increase the oxidation number, and reduction, you decrease the oxidation number. Talked about that. And we'll work on these examples in class.